Alright, so today I'm going to be working on a 2005 Pontiac Grand Prix, and it has the 3.8 liter, and we're going to be talking about the oxygen sensors. So there is one. The first one is right back here. And then it leads down there, so right there you can see a little bit of the cat. And if we go under the vehicle, you can see that's where the cat is, and there's your second one, which is reading after the cat. Alright, so now that we've seen where they are, right, so this is our first one that we saw, which was right after the exhaust manifold. So you're going to have your low and high ref signals going from the actual O2 sensor to the PCM. And then if we scroll up just a little bit, this is the actual heater part. So it should have a full 12 volts coming from the PCM. If we follow this wire, you'll see that pink is what actually supplies the voltage. Right here from the fuse block, goes from fuse 14, and once this relay is connected from hot at all times, it should get power. So following up on that, if you follow this diagram back down, it uses the same power source from that same exact fuse, and right down you'll find the second O2 sensor, which is after the cat. Again, it's got your high and low ref signals to the sensor, and then it's grounding it right here from the PCM, and then getting your 12 volts power.
Okay, so something else I wanted to add was that these sensors are pretty delicate, so when you're handling them, be careful. And another thing is that if you're struggling to remove it, do not try and force it. Something you could do to help is actually run the engine for a little while, and that will heat up the O2 sensor, making it a little bit easier to get out.
Alright, so I moved over to a 2016 Camry with a 2.5 liter. And our Grand Prix was not starting, so we had the car just running, and we're getting a reading of about 3.2 ohms. We are back probed, or reading the resistance across the upstream O2 sensor, and that 3.2 ohms.
Okay, so I just kind of wanted to take a break here real quick and show you what we were actually going through. So we were taking pin 1 right here and going across to pin 2 and testing the resistance between the two. So right here it says tester connection between 1 and 2, and your condition should be 1.6 ohms to 3.2 ohms. And you should be getting that reading around 68 degrees Fahrenheit.
Alright, so we are back probed into wire 3, or pin 3, sorry. And right now we're getting a voltage of 3.3, and it's connected to ground on the other side. Alright, so we are currently back probed on our...
Okay, so as you can see, coming out of our sensor, we have our 4 wires. That is our battery positive, which is the black wire, and the ground for our heater. And pin 3 and 4 are both our high and low ref signals for the sensor, which is what we are currently back probed into, so we can get a reading.
We're getting about 0.4 reading. Now that's supposed to be as close as possible to 0.3, so we're getting an okay reading. And now we're going to create a vacuum leak to show how that will change this reading.
Now,
Take it off completely.
Really up until now that we actually saw a change in the voltage right before it was about to die, because it was not liking having the unmetered air.
alright, Miller is going to create our false air problem again. I think he succeeded because idle just became a bit rough. I'll see. Is cutting out feel like crazy, both long and short term, with our false air problem? And it's hanging rich. It's running very rich right now. which is kind of ironic. It wants to cut out as much fuel as possible over the long term, but it's super rich. Alright, 3,000 RPM. Here we go. It wants to cut out as much fuel as possible with our false air problem. 30 is essentially where the limit is before it won't let you cut any more fuel after that, the PCM. It should be setting a DTC.
It did actually end up setting a code. It was a code P0031, which was a oxygen air fuel sensor heater control circuit low. And unfortunately, the scan tool was a little difficult to read, so I had to write over it. All right, one last thing I wanted to go over before ending the video was lambda. When we were going over the PID readings, we could see that our lambda ratings were about 1. And if you don't know what lambda is the actual ratio of our air to fuel ratio to compared to stoichiometry. So as we saw, most of the time it was at 1, which is where you want it to be almost all times. And so you could see anything below that is going to be rich because it is lacking air, and anything above that is going to be a lean reading. So during our PID readings, you could see that maybe a couple times when we were giving it a little bit less air with the vacuum leak, it might have been running a little bit rich. And because it was running a little bit rich, you may have seen the voltage drop slightly.